Okay, so let's look at something over here. Most of you see this question. We have here Ca plus and Ca. These are two different things. This is an ion. This one is an atom. Atom normally does not have charge. They have not undergone any chemical reaction. Ion over here has a charge. And this is what is telling you that they have lost or gained electron. Whenever you see plus, 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 that was what makes them metal. So automatically, anytime you see an ion having plus on top of it, it should tell you that it's a metal. And that's what a lot of students get confused. Sometimes they will bring it. Which of this is a metal and which of this is a non-metal? They will put this. They start to make it Ca2 plus. Then you see the right Ca. The moment you see Ca and you see Ca2 plus, it should tell you that this one is automatically an ion, because ions are the ones that have the plus, the charges on it. Atoms do not have it. And that's what a lot of students get confused. So they can mix it together, but always check the one that has the sign, either positive or negative here. Either positive or negative is an ion. But if it does not have any sign or charge on it, it is the atom. So you always have to take note of it very well. It's very important. Next, this is an ion. Why is it an ion? And this is not an ion. Now, let's look at calcium itself. Calcium has an atomic number 20, right? So 20, its shell is this way. We have it this way. Let's draw the electronic configuration. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have here 11, 12, 13, 14, 15, 16, 17, 8. Remember that it has to be 8. Maximum 8 here, maximum 8 here for the first 20 elements. Then over here, 19, 20. So I have the 20 over here. You get it? Good. Now, since I have this 20 over here, this atom have to be stable. So when it's being stable, for it to be stable, it has to lose 2 electrons. I've explained that in my earlier video, why it is a metal, because they donate their outermost electron, and here their outermost electron is 2. So it will give out this outermost electron. So when it gives out 2, that is the 2 here. But why? The question is, why is it plus? Now let's see why it is plus. First of all, we know that whenever we talk of an atom, the number of protons is equal to the number of electrons, and the same as the atomic number, which is represented by Z. That is it. These are the same. So it means that number of protons equals the number of electrons, right? Now, at this stage, let's look at this atom, calcium. It has not undergone a chemical reaction. So here it is 2, 8, 8, 2, because it's the 20th. Good. Now, this is how it is. Are you getting it? So here, protons for this calcium, this element is what? 20. Electrons are what? Also 20, because it's stable. Now, it's going under chemical reaction, going to give out these 2. So if it gives out these 2 out, now it becomes Ca288. Are you getting it? It has given these 2 out. So now let's look at something. Protons. Protons, they don't move. The one that are inside there, these are the way the protons are. They are inside the nucleus of an atom, the P. So for them, they don't change, irrespective of the reaction that takes place. So it's still 20. And the electrons here now, how many are they? 8, 8, 2. 18, because 2 is gone already in chemical reaction. Good. So electrons here are now 18. Now, let's come to the interesting part. Protons automatically, we know they are positively charged, right? So positively charged. Electrons are what? Negatively charged. So this is it. Now, let's do the permutation of the calculation. So positive 20 minus 18 will give you what? Exactly, positive 2. That is why we write 2 plus over here. So here, when it becomes an ion, we write it Ca plus 2, but we bring the 2 first, 2 plus, and that is how it becomes 2 plus over there. Let's see for the negative areas, that is the anions. So let's look at oxygen. Why oxygen is 2O 0, 2 minus. So let's look at oxygen now. Now, oxygen has an atomic number of what? 8. It's 2, 6. So here it is stable. It has not undergone any chemical reaction, the atom. So its number of protons automatically become what? 8. Number of electrons automatically become what? 8. And we know that protons are positively charged, as I said. Electrons are negatively charged, as you see here. So this has not undergone any chemical reaction. Now it is undergoing chemical reaction, meaning that this one have to be 8 at the end, as I said. So it means it needs 2. It is too much. So it just have to receive few to be stable. That is why when it receives, it becomes a non-metal, as I explained in my earlier video. So it has to receive plus 2 to be stable. But why is that we don't write plus 2? Let's see why. So here to say it has to be stable. So now it undergo chemical reaction. You are going to get O2 8. You get it? It was 6. We have added 2 to it. So now 8 over here. That is where it becomes an ion and a chemical reaction to be stable. So now here protons, normally they don't change. So protons are already 8. Electrons now over here, how many? Let's count. 2, 8. They are 10. I'm going over. The reason why it is 10 because the electrons are the ones that move around these shells. And they are the ones that normally move out. These protons didn't move. Good. So let's come back. So now we have here negative. So now let's see. Plus 8. You know electrons are negatively charged. Minus 10 is going to give you what? Negative 2. So that is why we write O2 minus, as simple as that. So basically, this is how metals and non-metals are formed. When they donate and they have a positive charge, they become metal. And they receive to become a negative charge, they become non-metals.